All right, so we're told the sample size is 100 people, so that means the total must be 100, so total must be 100. I know there are males and females, and then there are righties, lefties, and lefties. So if I look at this Venn diagram, the overlap of female and righty must be females who are righties. If these are females who are righties, then this must be females who are lefties, because they're still females, but they're not right-handers. If these are all the right-handers, these are females who are right-handers, so this must be males who are right-handers. And the only thing left is males who are lefties. So if I know that there are females who are righties, so that is 47. Males who are righties, that is 43. So altogether there's 90 total righties, that means there's 10 lefties. And since there's 3 female lefties, then this means there's 7 male lefties. So this is 7, 3, which totals up to, sorry, that's not right. There are 7 male lefties and 43 male righties, which totals up to 50. There are 3 female lefties and 47 female righties, which totals up to 50, which gets you to your 100. So probability of being a lefty, there are 10 total lefties out of the 100. That's 10%. Probability of being female, 50 out of 100, or 50%. Probability of a male, same thing. Probability of being left-handed, given that you're female. So if I only look at the females, there are 50 total females. Of the 50, 3 of them are left-handed. So there's a 3 out of 50 chance. Which, if, let's see, that should end up being 6%. Multiply by 2, we get 6 out of 100. And then probability of lefty being a male, that would be 7 out of 50, or 14%. And then, let's see, last one, number 11. We have 685 total, so that's the sample size. Now I'm told that I have percentages here for each of those things, so I need to figure that out. So 62% of 685 is 424.7, so I'll round that to 425. 38% of 685 is 260.3, so I'll round that to 260. And if I do 260 and 425, that does add up to 685. Now what I have to be careful of is that it's 40% and 60% is broken down. Of this 260, it's broken down. So 40% of 260 is 104. And 60% of 260 is 156. That 425 is broken down into certain percentages, so 425 times 0.58 gets you 246.5, round that to 247. 42% of 425 gets you 179. Which is going to give us 1 too many. What do we miss? Did I round right? 425 times 0.58, 246. Weird. Well, one of them is just to round down when you should round up. Not sure which one. So that's just a mistake in that thing, but for the most part, we can get this fairly right. So males, there's a total of 425 males. 247 will say eat. 178 doesn't. Females, there's 260 total females. And then 104 eats. 156 doesn't. You can add these up and add these up to get it. Again, probability of eats, that's all the people who eat. So I would need to know that total. That looks like 351 out of this 685. E and M, so which are eats and male, that's 247. Out of our 685. E and F, so eats and female, there's 104 of those out of 685. Eat, given that you're a male, so out of all the 425 males, 247 eats. And eats, given that you're female, there are 104 eats out of the 260 females. You could fill in the diagrams from here. Just remember that you should have separate things. So you could have like male and eats. If you had male and female, then the overlap would be someone who's male and female, which does not make sense. So, at least in terms of this problem. So we have males and eats, so this would be males who eat. This would be people who eat but aren't males, so that would be females who eat. These would be males who don't eat. And then these are females who don't eat. All right, that's it for that.